Hello, dear students. Welcome back to your math classes. How are you all? I hope you all are healthy and doing well. So, students, I'm your mathematics educator again here with a new chapter and a new concept. And today we are going to learn about chapter number 5, which is factors and multiples. So, we already learned about the division and the multiplication. So, this will be helpful for us to finding out the factors and multiples in this chapter. So, first we are going to learn about the factors. We know the following facts. The product of two numbers is a number. 5 multiplied by 7 is 35. 5 and 7 are the factors of 35 because 35 is divisible by both by 5 and 7. So we already learned about factors and multiples in our earlier classes, and in that time we understood about this. If we have two numbers 5 and 7 and the product of it is 35, so we can easily say that the factors of 35 will be 5 and 7. Right, students? Well done. Now, besides 5 and 7, 1 and 35 are also factors of 35 because 35 is divisible by both 1 and 35. Therefore, we can say 1, 5, 7 and 35 are all factors of 35. So, a number which divides a given number without leaving any non-zero remainder is called a factor of the given number. So, end of the moment, what we understood is when a number is when a given number is dividing a number without leaving any remainder, that it's called the factor of that number. Now, we also know that operation of division is the inverse of the operation of multiplication. For example, 3 multiplied by 4 is equal to 12. Hence, 12 divided by 3 is equal to 4, and 4 divided by 12 divided by 4 is equal to 3. And so 3 and 4 are factors of 12. So is there any other factor of 12? Yes, it here 1, 2 and 6, 3 and 4. These are the factors of the 12. So we express 12 as a product of two numbers in different ways. For finding out factors of given numbers, we express the given numbers as a product of two numbers such that the first number in the product is less than or equal to the second number. So by doing this, we can easily identify the factors of the given numbers we have. Now, a number can be divided without any remainder by each of its factors. One is a factor of every number. Every number is a factor of itself. A factor of a number is smaller than or equal to that number. So what we identify here, if we have a given number, so the number which is divisible by that number without leaving a remainder, that is the remainder of that number. One is the factor for every number, and every number is a factor itself also. Now, a factor could be lesser, smaller, okay, equal to that given number. Now, methods of obtaining a factor. So, for example, dividing 28 by 1, we will get 28. So, in this case, 1 and 20 both are the factors of the 28. Now, dividing 28 by 2, so we will get 14. So, 14 is all 2 and 14 are factors of 48. Now, 28 divided by 3, so in this case, we have a remainder which is 1. So, 3 it's not a factor of 28. Now 28 divided by 4, so we will get 4 and 7. So both are the factors of the 28. So end of the moment, what we observe, 1, 2, 4, 7, 14 and 28 are the factors of 28. Is 7 a factor of 150? Let's find out. So what we see when we divide it, end of the moment we have a remainder. And we already learned in the definition of factor that we don't have any known zero remainder when we divide our number with its factors. So in this case, 7 is not a factor of 150. Okay. Now we move forward to our exercise 5.1. 3 multiplied by 11 is 33. So 3 and 11 are the factors of 33. 6 multiplied by 8 is 48. So 6 and 8 are the factors of 48. And now this is for you. You have to do it yourself. Check whether or not the first number is a factor of the second number. So you have to divide it. So we already know that 3 6 are 18. So there is non-zero, no remainder. So we can say that yes, it is a factor. 3 is a factor of 18. Now 4 and 14. So 4 3 are 12. 2 will be the remainder. So in this case, this is not a 14. It's 4 is not factor of 14. So the same process you have to repeat here for the rest of the questions you have in question number 2. Next question, give all the factors of these numbers. So we have to find out the factors. For 6, we have 1, 2, 3, and 6. How we find it? 1 multiplied by 6 is 6. 2 multiplied by 3 is 6. 6 multiplied by 1 is 6. So these all are the factors of the 6. So the same process you have to repeat for the rest of the questions you have in rest of the parts you have in question number 3. So students, this is the end of our factor concept. Now we are going to learn about the multiples. So we know that 2 multiplied by 4 is equal to 8. So 2 and 4 are factors of 8. The same fact can be described in the another way. We can say that 8 is the multiple of 2 and also 4. Okay. So in previous we say that factors of 8 are 2 and 4. But in case we can say that the 2 and 4 are the multiple of 8. So the word factor and multiple signify mutually opposite relationship. Each of the numbers 2, 4, 6, 8, 10 can be divided by 2 with 0 as remainder. So 2, 4, 6, 8, 10 are multiples of 2. So every number which can be divided with non-zero remainder by a given number, it's called a multiple of the number. So every number which can be divided with 0 remainder by a given number, it's called a multiple of the given number. So multiples of 3 are 3, 6, 9, 12, 15. In multiple now, we cannot say divide with a 0 remainder because we already learned this that this is the definition for more profoundly for the factors. In this case, for the multiples are unlimited. You can multiply a particular number with any number and we have so many numbers. So you have to identify this difference between factors and multiples. That is my whole thing which I want to explain you. Now method of obtaining multiples, you can simply multiply any number with the particular number, you will get your multiples of a given number are obtained by multiplying the given number by 1, 2, 3, 5. Any number you can multiply with the given number, that is your multiple for that number. Tables of numbers are useful in finding multiples of a number. Now let us find multiples of 1. So you can multiply 1 with any number, those numbers are your multiple of 1. Every number is a multiple of 1. Okay, every number is a multiple of itself. The same thing which we learned in factors. Multiple of any number is greater than or equal to that number. In factors we have smaller or equal. In multiple, we have greater or equal. Every number has numerous multiples. Numerous multiples means so many multiples. You can never count them because we have so many numbers. You can multiply a given number with any number to produce it multiple. Now we move forward to our exercise. Write the first smallest three multiples of the numbers given below. So first 5. So you just have to read the table of 5. 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20 and 5 fives are 20. 5 for 10 again 10, 20, 30, 40 and 50. So in same way you just have to read out the numbers table till fifth place and you will get your answer. Now we move forward to our question number 2. State whether or not the first number is a multiple of second number in each of the following. So 3 multiplied by, yes, 3 is a multiple of 15. 4, it could not be a multiple of 42 because we cannot multiply it na. No, this is not. It could be a multiple of it. Now fill the blanks. Every multiple of a number is greater than or equal to the number. The multiples of even number are always even. So students, you have to do the rest two parts your own. So do it yourself. Now we move forward to our next concept, which are prime numbers. So according what we understand by prime numbers, those numbers which have only two factors, 1 and the number itself. So number 1, it's not included in the list of prime numbers. It is also not included in the list of composite numbers. We consider 1 as a special number. 2 is the smallest prime number. A prime number can be divided by 0 remainder only by 1 and by the number itself. So we have only two factors, 1 and the number itself. Composite numbers can be divided with 0 remainder by 1 by the number itself and also by the numbers which are the factors of the given composite numbers. So in that case, how can we classify between prime numbers and composite numbers? In prime numbers, we have only two factors, which is 1 and the number itself. And in composite number, we have more than two factors and it can any number which is divisible by that given number without leaving a remainder. Okay, now we have co-prime numbers. So in this case 3 and 5 and 5 and 7 and 7 and 9, if two numbers have only one as a common factor between them, they are called prime numbers. So in 3 and 5, 5 and 7, 7 and 9, in all these group of numbers, what we see here, that we have only one as the common factor between them. This is called your co-prime number. 12 and 15, we have 1, 3. So it means we observe that 1 and 3 are common factors for 12 and 15. It means these are not your co-prime numbers. Now we have factors and prime factors. Now we know that when we multiply two or more numbers, we get a product. These numbers are called the factors of the product. Let us study the factors of 20. So in this case, you have to find out the factors. So the factors for 20 is 1 multiplied by 20, 2 multiplied by 10, and 4 multiplied by 5. This could be your factors. We know that 20 can be divided exactly by 1, 2, 4, 5, 10 and 20. Among the factors of 20, 2 and 5 are the prime numbers. We say that 2 and 5 are the prime factors of 20. So what we notice here, we first have to find out the factors. Okay. While once you calculating your factors, now you have to identify in the factors those are the what are your prime numbers. You just have to take it out and you will say that the prime numbers you will find out in your factors list. So those are your prime factorization. For example, 2 and 5 both are prime numbers, so this is your prime factorization, prime factors. Now we have prime factorization. If we are asked to find the prime factorization or the product of prime factors of a number such as 24, it means that we have to find prime factors that will be a product of 24. The prime factorization of product of prime factors 24 is 2, 2, 2, 3, but the prime factors of 24 are 2 and 3. Okay, let's understood it. We have two methods to find out prime factorization. The first, division method, and the second, factor tree method. So first we understand about the division method. 40 divided by 2, 20, 20 divided by 2, 10, 10 divided by 2, 5, 5 divided by 1. So what you notice here, in prime factorization, we are only using prime numbers. 2 and 5 are the prime numbers. Okay, so now we are going to learn, and now we are going to find prime factorization with factor tree method. So 40 will be 2 and multiply by 20, 20 will be 2 multiply by 10, and 10 will be 2 multiply by 5. So these your prime numbers, 2 multiply by 2 multiply by 2 multiply by 5, 40. These are your prime factorization. Okay students, so next we have highest common factor, or you can also say greatest common factor, GCD and SCF. We are going to learn this. So let us find the SCF of 12 and 18. So the factors of 12, we already know that we have 2, 3 and 6 factors of both 12 and 18. How? These are the factors of 12 and these are the factors of 18. So in this, what we notice, the common factors. 2 in this, 2, 3, 3 and 6 and 6. So these are the common factors we have. Now therefore, 2, 3, 6 are the common factors of 12 and 18. And which one is the greater one in 2, 3 and 6? We already know that 6 is the greatest among 2, 3 and 6. So this is your SCF. SCF is highest common factor. So in these, we have highest number which is 6. That is why this is our SCF. Now 36 and 48, same, we have these common factors, and among this 12 is the greatest. So we can easily find out SCF of 36 and 48 is 12. Now long division method to find out HCF. For this, find the HCF of 192 and 120. So the smaller number is a divisor and the bigger number is become your dividend. Now we have to divide 192 by 120. First we take 120, we will get 72. Now in this case, again and again we have to change our divisor and dividend. Okay. So the smaller number is always your divisor and the bigger number is always your dividend. So in this case, we get 72. So 72 is smaller as compared to 120. So 120 will become your dividend and 720 will become your divisor. So 120 divided by 72, you will get 72 because the 72 twice is bigger as compared to 120. So we get 72. 48 divided by 72, 48 minus 24, 24 divided by 48. So we will get 0 end of the movement. So what we notice here, that 1 1, so the end of the movement, the 24, by the which number get your remainder as 0, that is your HCF, okay, by using long division method. So the 24 is the HCF of 192 and 120. So now we are going to learn about the HCF of three numbers. If the HCF of three numbers is to be found, then first find HCF of any two numbers, then find the HCF of the third number and the HCF of 10 of the two numbers. The last HCF will be the required HCF of three given numbers. So in this case, for example, if we have three numbers, so first we have to take two pair, the first two numbers, and we already know that the bigger number will be your dividend and the smaller number will be your divisor. 665 divided by 399, you will get 262. Then 262 is the new divisor for your 399. Then you have to divide it. Then you have 133, which is divisor of the 262, and you will get 0. So now this 133 will be your divisor for the third number we have, which is 1444. So the same process we have to repeat here. For 144, we have to take 133 because the twice of 133 will be greater than for 144. Then the number we have 114 as a new divisor for 133. After we have to take 133 minus 114, we will get 19. 19 divided by 114, you will get 0 as your remainder. So end of the movement, what you have to write here, that 19 is the HCF of 399, 665 and 1444. Okay students, now we have a special case. For example, if there are two prime numbers among the numbers or two numbers are co-prime, then their HCF will be 1. Let us find out the HCF of 15, 16 and 20. So 15 is equal to 3 multiplied by 5. So 3 and 5 both are prime numbers, and in this case 4 times 2, it's also a prime number. So 15 and 16 only have a 1 as a common factor. So what we have to observe, that their HCF is 1 only. Okay. Now we have common multiples and least lowest common multiples. So in the previous section we learnt about the factors, and now we are deal with multiples only. Okay. So multiples of 2 are these, multiples of 3 are 3, 6, 9, 12 these. So common multiples of 2 and 3, we can say 6, 12, 18 are multiples of both 2 and 3. So similarly, we can find out, and end of the moment, what we notice here, that if we have two numbers, when we are working with large numbers, it is easier to show our working as follows. For example, find the LCM of 12 and 15. So here we have our example 12 and 15. So continue dividing by factors of 12 and 15 until the result is 1. So we have to divide it until we get 1. So 2 in 2's table 12 at the place of 6, but 15 is not coming. So we have to write 15 as it is. So 15, then 2, 6, 3, 15 not coming. So as it is, we have to write 3, 1, 15 for 5 and 5, 1 and 1. So 2, 3, 2, 2, 3 and 5 are the LCM factor, LCM of 12 and 15. Now, so 2, 2, 3 and 5 are the multiples of 12 and 15. For getting LCM of it, we have to multiply these numbers together and you will get your answer, which is 60. Now the same process for 50, 28, 45. What you have to keep in your mind, if a particular number, it's not divided by your given number or the number you taken, so what you have to do, you just have to write that number as it is and continue your calculation. And for that number, you can opt a different number. For example, here we take 3, and by 3 we divide 15, 5, 9, 3, 45 and 15. So we have to continue till we get our result as 1. End of the moment, we have these multiples of 15, 18 and 45. We have to multiply them together and we will get our answer. Now we are going to learn about the relationship between HCF and LCM. So we have to find out HCF of 24 and 36 is 12 and LCM of 24 and 36 is 72. So by multiplying 12 and 72, we will get the product of two given numbers, that is equal to. So product of HCM and LCM, product of two given numbers. So we can say that this is our formula. If we want to find a missing thing between, if we want to find a missing thing as SCF LCM, so we can change our formula as well. For LCM, first number multiplied by second number divided by SCF, and for SCF, first number multiplied by second number divided by LCM, and we will get our answer. In suppose case we have to find out our first number and second number, then what we have to do? SCF multiplied by LCM. If we want to divide first number, if we want to find first number, we have to divide it with the second number, and if we want to find out our second number, then we have to divide it then we have to divide it with the first number. For example, find the LCM of 324 and 729 with the help of their HCF. So first we have to find out the LCM of 320. First we have to find out the HCF of the given numbers. So what we found here, that 81 is the HCF of 324 and 729. Then the first number 324, the second number 729 is divided by 81. You will get your answer. So the same procedure we have to do here when we have a missing thing in our formula. Now we shift to our exercise 5.3. So find all the factors of 36. So we can easily say 36 common factors are 1, 2, 3, 4, 6 and 12. So these are the factors of 36. So in same way, you can find out the factors of the rest of the parts you have in question number 1. You just have to keep in your mind, you just take those numbers which are exactly divisible by your given numbers and not left with any non-zero remainder. Now write all the prime numbers between 1 to 50. So you already know about the prime numbers 2, 3, 5, 7, 11, 13. So in same way you have to continue this procedure and you will get your numbers, prime numbers between 1 to 150. Now find the prime factorization of 24. So 24, now we take 2, 12, 2, 6, 2, 3, 3, 1. So these are your prime factorization numbers for 24. 2, 2, 2 and 3. Now find the SCF of the following numbers. So SCF of 24 and 36, you first have to find out the common factors of 24. So 1, 2, 3, 4, 6, 8 and 12. In 36 we have 1, 2, 3, 4, 6 and 12. So 12 is the common factor between 24 and 36 and highest also. So 12 will be your answer. Now find the SCF of the following by long division method. So in long division method, what we have to do, we just have to keep change our dividend and divisor to find out the HCF of the given numbers. So here we have to divide 1150 with 800. So we subtracted 0, 5 and 3. Now we have to divide 800 by 350. So we have 700. We get 100. Now we have to divide 700 with 100. So we get 700 and at of the moment we have a remainder 0. So what we have to say, 100 is the HCF of the 800 and 1150. So the same procedure you have to repeat for the rest of the parts you have in question number 5. Now move forward to our question number 6. Find the LCM of, so we have to find out the LCM of 48, 72 and 96. So first we take 2, 24, 36, 48, again 2, 12, 18, 24, again 2, 6, 9, 12, again 2, 3, 9, 6, again 2, 3, 9, 3, then we take 3, 1, 3, 1, 3, 1, 1, 1. So now we have to multiply this number together. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 3s are 3 2s are 6, 3 3s are 9, 96 3s are 3 6 are 18, 1 3 9s are 27, 28. So 288 is the LCM of 48, 72 and 96. So you have to repeat the same concept and same procedure for rest of the parts you have in question number 6. Now move forward to question number 7. So now we have to take a SCF and LCM of 1225 and 2100. So what we do, first we do the separately the LCM of 1225. So 5, 2, 4, 5, 245. Then we have to take 5 again, 4 and 9. For 49 we take 7, 7, 7, 1. So these are the LCM for 1225 and then we take LCM for 2100. So we have 3, 700, then 700, then 5, 20, then 5, 4, then 2, 2 and 1. So these are the factors we have. So in case what you have to do here, you have to find out the lowest common factors between 1225 and 2100, that is your LCM, and then by putting those values into your formula you will get your answer. So now we move forward to our question number 8, which is LCM of two numbers 24 and 288 is 288. Find their SCF. So LCM of two numbers 24 and 288 is 280. Find out the SCF. So we already know that if we have two numbers, so we multiply 24 multiply by 28 and LCM is 288 to find out the SCF. So this is our formula. 288 will be cut it down with 288 and end of the moment we left out with 24. It means SCF is 24 only. Now LCM and SCF of two numbers are 13,000, 1,38,516 and 97 respectively. If one number is 22,037, find the other number. So we already know about the formula we have. You just have to put down the values into that formula and you will get your answer. Now we move forward to the now we are okay. So in question number 10, the same process you have to repeat here, so you can do it yourself. Now move forward to a new concept, which is test of divisibility. So by doing this, you can easily identify those numbers which are exactly divisible by the given number or not. For example, if you have to find out the given number is divisible by 2, so what you have to notice is if the end digit of that number is 0248, so you can simply say that the number is divisible by 2. Next, divisibility by 3. So in this case, if we have a number 108, so 108 is 1 plus 8 is equal to 9. So 9 is divisible by 3. It means 108 is also divisible by 3. A number is exactly divisible by 3 if the sum of digits contained in it is divisible by 3. For example, 108, 96, 321, samely. Now divisibility by 4. A number is exactly divisible by 4 if the number formed by its last two digits, tens and ones is divisible by 4. For example, so in this case, for example, you have 532. So you have to notice only the last two digits. 32 is divisible by 4. It means the given number is also divisible by 4. Now we move forward to divisibility by 5. A number is exactly divisible by 5 if its last digit is 0 or 5. For example, in 70, 85, 1150, what we notice? We notice that the last digits are 0 and 5. It means it is divisible by 5. Now divisibility by 6. A number is exactly divisible by 3. A number is exactly divisible by 6 if it's divisible both by 2 and 3. For example, 54, 516, 918. So in the test of divisibility, you have to fulfill the conditions you have in divisibility by 2 and divisibility by 3 to complete this section. Now we move forward to divisibility by 7. There is no exact test for divisibility by 7. To confirm a number has to be actually divided by 7. So for divisibility by 7, we have no any procedure for it. Now divisibility by 10. So in this case, a number is exactly divisible by 8 if the number formed by its last three digits. In number formed by hundreds, tens and ones digit is divisible by 8. So it means, for example, 200, 2000, 100, 112, you have to notice these three last digits. If these three last digit is divisible by 8, it means the whole number is divisible by 8. Now in this case, if you notice 424, that is divisible by 8. It means the whole number is divisible by 8. Now divisibility by 9. So the same procedure which we do in our divisibility test of 3, we have to repeat here. A number is exactly divisible by 9 if the sum of its digit is divisible by 9. For example, 72, 279, 4405, 4, 7 plus 2 is equal to 9. And 9 is divisible by 9. It means 72 is divisible by 9. So you have to separately add them together, and the product and the sum of it is divisible by 9, then it is your whole number is divisible by 9. Now divisibility by 10. For divisibility by 10, you just have to notice the last digit. If you have last digit 0, 0, 0, it means the given number is divisible by 10. Now the divisibility test by 11. In this case, you have to keep in your mind, first you have to divide those numbers into even number place value and odd number place value. For example, a number is exactly divisible by 11 if the difference between the sum of the digits in the odd places and the sum of the digits in the even places is divisible by 11 or 0. For example, you have 2, 9, 6, 2, 3. So first you have to divide the place value into even places or odd places. So 2, 6, 3. Odd, even, odd, even, odd. So 263 is equal to 11 and 9 plus 2 is equal to 11. 11 minus 11 is equal to 0. In this case, what you can say that the given number is divisible by 11. You have to fulfill the two conditions. First, the difference will be 0, and the second, the difference what you got by subtracting even and odd places, it divisible by 11. That if these two conditions are fulfilled here, then you can say that the given number is divisible by 11. So now we have divisibility test by 12. A number is exactly divisible by 12 if it is divisible by both 3 and 4, because 3 and 4 are the factors of 12. So if the given number is fulfilled the conditions for 3 and 4 divisibility test, then you can say that the divisibility test, the given number is divisible by 12. Now you have your worksheet where you have combination of questions which you already do in your exercise. You have to do here. After completing this is the end of your chapter. I hope so students you like this chapter and understood it very well. If you have any kind of doubt, what you have to do, you have to repeat the whole content and try some different question related to that particular topic. So students, now I'm going to meet you in your next class. Till that, bye bye. Have a good day.